Hello everyone. Today in this video we'll discuss about what is linear differential equation and different types of linear differential equations and the solutions. So this topic is about linear differential equation. So let us see what is linear differential equation. Basically, a differential equation is said to be linear if the dependent variable and its derivatives are of first degree. So I'll repeat it. A differential equation is said to be linear if the dependent variable and its derivatives are of first degree. So let me take an example. So d square y by dx square plus 3y plus 4 is equal to 0. This is a differential equation. Why this is a differential equation? Because we have differential terms. And what is a dependent variable here? So y is a dependent variable. Y is a dependent variable and x is independent variable. Independent variable. So a differential equation is said to be linear if the dependent variable and its derivatives. So this is the dependent variable and its derivative. So we have a derivative term or differential term which is nothing but d square y by dx square are of first degree. So let me see what is the degree of this differential equation. So since we have differential term whose power is 1, so I can say this is having a degree 1. So this is a differential equation with degree 1. So this is known as linear differential equation. Linear differential equation. So let me take one more example. D square y by dx square whole square plus 4 dy by dx plus 15 is equal to 0. So this is a differential equation and it has got differential term in it. So this is a differential equation. And what is the order of this differential equation? Order is 2 because maximum times we are differentiating is twice. So the order is 2 and the power or index of that differential term is 2. So degree is also 2 here. So here, since the degree is 2, it cannot be a linear differential equation. So this is not a linear differential equation. Why this is not a linear differential equation? Because in the definition itself it is clear. Differential equation is said to be linear if the dependent variable and its derivatives are of first degree. But here in this equation, the dependent variable is having second order, but it is having degree 2. So it is not 1. So it is not a linear differential equation. So let me tell you about standard form of differential equation. Standard form of linear differential equation. Linear differential equation. So when we discuss this topic, you have to remember the definition of linear differential equation because you must be able to identify what is linear differential equation. So we'll see what is the standard form. So standard form is dny by dxn. That is nothing but dependent variable is differentiated n times plus a1 dn minus 1 y by dx to the power n minus 1 and so on. I'll write last few terms. So it is a n minus 1 dy by dx plus a n y is equal to phi of x. So this is a standard form of differential equation. So about these terms, these are the differential terms, and this is the dependent variable, and this is independent variable, that is x. And along with all these terms, we have some other terms. Those are a1, a2, and so on, an minus 1, comma an. All these are constants, or you can also call these constant coefficients. Constant coefficients of linear differential equation. So we have seen what is the standard form of linear differential equation, and all these a1, a2, an minus 1, and all these are constant coefficients. So every time to write this or in this format, it is difficult because we have to write the number of times the independent variable is differentiated. So it will be difficult for us to write all these notations. So let us simplify it. So we'll be using a operator known as a differential operator. Differential operator to write the differential equation. So let me tell you how to write differential operator. So if suppose we have dy by dx, derivative of y with respect to x, then we can replace it with dy. So where d is differentiation with respect to x once. And if suppose we have d square y by dx square, how to write differential operator or in the form of differential operator? So we can use d square y. So this is in the form of differential operator, where d square is nothing but d square by dx square. So similarly, you can write d to the dn y by dx to n. So this is nothing but dny. So where dn is known as or as the differentiation n times with respect to x. So this is differential operator. So d is very important term here. So this is differential operator. So now we have seen what is differential equation, we have seen what is the degree, what is order, and then we have discussed about linear differential equation, then we have seen differential operator. Now let us see how to write standard differential equation in terms of differential operator. So I can write standard differential operator, which we have written previously, in terms of differential operator like this: dny a1 dn minus 1 y plus a2 dn minus 2 y plus and so on, and last few terms an minus 1 dy plus an y is equal to phi of x. So this is the equation or standard differential equation in terms of differential operators. So this can also be written as in a simple way, that is f of dy is equal to phi of x. This is the notation. Now, depending on the value of phi of x, we can divide or we can classify differential equation into two types. First one is homogeneous differential equation. Homogeneous differential equation. And the second one is non-homogeneous differential equation. So what is homogeneous differential equation? So that depends on what is the value of phi of x. So if phi of x is equal to 0, then we can call it as homogeneous differential equation. So if phi of x is not equal to 0, any other value, then we can call it as non-homogeneous equation. So that's it for today. Thank you.